right? So today we will solve this question where two triangles are given. Okay, this is a question from similarity, but we will use other concepts also to solve this. So in this question, triangle EDC, right? Which triangle? EDC. That means E is here, D is here, and C is here. EDC is similar to triangle EBA. Triangle EBA, this is the sequence. So you can see EDC similar to triangle EBA. So just follow the sequence. Here you can see triangle EDC similar to triangle EBA. And if two triangles are similar, then their corresponding angles are similar. So here this angle, that means angle for triangle EDC, let's say triangle D, that means the angle which is lying in between angle EDC will be equal to angle EBA, right? EDC EDC is 70 degree, so EBA, that is angle 4, will be also equal to 70 degree, but we will prove it separately. Okay, since two triangles are similar, we can say the corresponding angles are equal, because for two similar triangles all their angles, corresponding angles are equal, right? Now here what we can do, you can see AC is a straight line, right? Alternatively we are proving it. AEC equal to a straight line AEC is an straight line, so can't we say that this angle AEB, that is angle 5, plus angle CEB, this one, is equal to 180 degree? Because for any straight line the angle formed will be linear pair, so angle AEB plus angle CEB, that means angle 5 plus angle 115, both these angles will add up to form 180 degree, isn't it? So we can say that angle 5 plus 115 degree, which is given to you, I'm not writing the angle name, so just you can angle 5 plus 115, when you add them it will be equal to 180 degree, right? So in this way angle 5 is calculated, isn't it? So angle 5 is calculated as 180 degree minus 115 degree, and what is the value? Just subtract it. 15 plus 5, 20 plus 60. So angle 5 will be equal to 65 degree. So this angle is calculated, right? Angle 5 is 65 degree. So this answer is known to you. Now just solve the other part. Similarly, angle, the line BED, it's an straight line. So we can see, since BED equal to a straight line, BED is a straight line, we can say angle 3 plus 115, both these will add to form 180 degree, isn't it? So angle 3 plus 115 degree equal to 180. So this will also give you the value of angle 3 equal to 180 minus 115 equal to 65 degree, and you can also cross verify it. Since these are two lines, then angle 3 will be equal to angle 5, and we have already calculated angle 5. So these are also vertically opposite angles. So anyway, we have calculated it, right? So angle 3 is calculated over here, angle 5 is calculated over here, right? Now, what is the value of angle 4? You can see, students, CD, I am just pulling it little down. CD and AB are two parallel lines, right? And BD and AC are two transversals. These will be acting like a two transversals. Though then we can't we say that angle 1 will be equal to angle 2, angle 70, this 70 degree will be equal to angle 4, right? If this 70 degree will be equal to angle 4, then we can say that the value of angle 4 is 70 degree, right? So here we will write angle 4 will be equal to 70 degree, being an alternate angle, being an alternate angle. Let me squeeze it little down. So angle 4, this will be equal to 70 degree, right? Being an alternate angle. Here Roger, Z do zero. I'm didn't getting you. Hi B. I'm not able to get your question. Sasquatch promise. Yeah, I can see 100 is the answer. Oh, is it? Let us see. Roger. Yeah. So, thank you so much for attaching. Okay, just like and subscribe, students, if you find it useful. Now we will go and find the other remaining angles. So angle 4, this was angle 4, and the value of this is calculated as equal to this one, that is 70 degree, right? Now this angle is calculated as 70 degree. Now, so you can see triangle EAB, it's an triangle. It's a triangle. If you are knowing this angle 5, if you are knowing this angle 4, then can't we calculate angle 2? So angle 2 is calculated by subtracting 5 and 4, the value of 5 and 4 from 180 degree, because the sum of all these three angles inside this triangle will be 180, right? So we can say in triangle EAB, let me squeeze it. So we can say that in triangle EAB, since it's a triangle, we know that the sum of all the angles of that triangle will be equal to 180 degree. So we can say that angle 2 plus angle 4 plus angle 5, this all will add up to give you 180 degree, isn't it? Now, the angle 2 is not known to you. So this will become a variable now. And angle 2 plus, you can put up the value of angle 4. Yeah, Roger. In triangle ABC we have, yeah, you can tell me what's that? In triangle ABC, but triangle ABC is not forming over here, Roger. Let me explain you. Because AB is here and C is here. If this B is connected to C, then only ABC will be forming, right? Sorry. So let me explain it, Roger. Then okay, we will discuss later. Okay, just solve this question, then we can interact. Thanks for being attached. Yeah, so angle 2 plus angle 4 plus angle 5 equal to 180 degree, and we have calculated the value of angle 4 as 70 degree. being alternate to this one. This 70 degree is known to you. So I put up the value of 70 over here and angle 5. What's angle 5? Angle 5 is this one. This is already calculated 65 degree. So put this value of 65 degree over here, right? This will add up to give you 180 degree as we have already written into the previous line. So this will give you the value of angle 2. So angle 2 is calculated here as 180 minus 70 minus 65. So 180 degree minus 70 minus 65. So this will give you 70 plus 65 is 135. 135 when we will subtract from 180, this will be giving you 55 degree. Right? So this will be 55 degree. And let us cross check. -180 minus 135. So it's not for 55, it's 45. It's a calculation mistake. So we can write it as 45 degree. 45 degree. So now all three angles of this triangle is calculated, right? Angle 2 is calculated as 45. This is calculated as 45 degree now. Now we have all the measures for this triangle. We have the value of angle 5, which we have calculated as 65 degree, which is equal to angle 3, which is 65 degree. So in triangle EDC, in triangle EDC, if angle 3 is known to you, this angle 70 is known to you, are not you able to calculate this angle, right? So just go into this triangle EDC. So in triangle EDC, this angle will be equal to 180 minus 70 minus this. So the value of this is 65 degree, right? So angle C is calculated as, let me write it over here. So in triangle EDC, sum of these angles, that means 70 degree, this angle, plus angle 3 plus angle 1 is equal to 180 degree, isn't it? How much is the cam angle worth, Roger? I am not getting you. ACB is 40 degree. Let us see. You have calculated ACB, but that was not required. Here in triangle EDC, just in the shaded triangle, you can see 70 degree plus angle 3 plus angle 1 will be equal to 180, right? So 70 degree plus angle 3, the value of angle 3 we have calculated as 65. You can see here, right? So angle 3 is calculated as 65. So put up the value of angle 3 over here, and in this way we will calculate the angle 1, because this is the only variable which is left with us. So from this equation, angle 1 can be written as 180 degree minus 70 degree minus 65 degree, right? So this will be giving you 180 degree minus 135 degree, right? And which will be equal to 45 degree. So now the final angle 1 is also calculated as 45 degree. And students, you can cross verify it. How? Let me show you. Since AB and CD are two parallel lines and AC is acting like a transversal, then angle 1 will be equal to angle 2 being an alternate angle, isn't it? Angle 1 is equal to angle 2. So angle 2 is already calculated by us. That is, we have calculated it as 45 degree. So if this is 45 degree, this angle will also be equal to 45, right? So here you can see we have also calculated it as 45. So finally you can see both in both the methods our answer is coming as 45. So our answer is correct, right? So we have calculated all the angles of these triangles, right? If you find it useful, you can go and like it and subscribe. Yeah, Roger, now we can discuss. How much is the scam angle worth? Oh my god. You are asking about the orientation of my camera? Definitely you are kidding. Thank you for your interest. Yeah, Roger. And finally, we have calculated this. Okay. Now, let us come to the second part of the question. Okay. The second part of the question is this one. Okay. Here, we need to, we have been given that triangle POS. POS, let's say here is O. POS and ROQ both are similar. So triangle POS and ROQ are similar. So we can, I'm just writing it again. POS similar to triangle ROQ, right? It's similar to triangle ROQ. Now, you know that if two triangles are similar, then their corresponding angles are equal, right? Then we can say that triangle POS, let's say this is angle 1, this is angle 2, and this is angle 3, right? And in triangle ROQ, let's say this is angle 4, this is angle 5, this is angle 6, right? Is it okay? So 1, 2, 3, 4, 5, 6. We have written the sequence over here so that it will be easier to understand, right? Now, since triangle POS, this triangle POS, this means this triangle. This triangle POS is similar to triangle ROQ. ROQ. This is similar to this one. That means this triangle is similar to this one. So we can see, you can see the sequence over here. From this triangle, this angle will be equal to this angle, right? In the similarity, this is the basic concept we are following, and you just take care of it. So this particular angle will be equal to this angle. How? Let us see. We can write it angle SPO. Angle SPO is equal to angle QRO. You just see the sequence in which I am taking SPO. First the last word, then the first, then the middle. So SPO. SPO is equal to angle. Similarly, in the same fashion, we will be taking the angle which is equal to it. So we'll follow the same sequence. That is first, the last one, Q. So write it, angle Q, then first, R, and then O, right? So angle SPO equal to angle QRO. So I explained it over here, but I will not going to explain it for all the angles because it will be taking time. So we can write angle SPO as angle 1, right? It will be easier to understand. That's why I have nomenclature, done the nomenclature. So angle 1 is equal to QRO. QRO, that is this one, angle 5. So angle 1 will be equal to angle 5, right? So we have to prove that PS parallel to QR. Since angle 1 is equal to angle 5, right? Similarly, can't we say that since 1 equal to 5, then PS and QR will be the parallel lines, and PR is the transversal, which is cutting both the parallel lines, and in this way angle 1 and angle 5 are the alternate angles. In the reverse way, we can say if the alternate angles between two lines are equal, then definitely these lines which are they must be parallel to each other, right? So since angle 1 equal to angle 5, this one alternate angle are equal, that means PS is parallel to QR. So in this way we have proved it. Okay, we'll also follow the another sequence. Okay, in triangle POS and ROQ, we have taken the sequence SPO and QRO. The first, the last letter, then first, then the middle one, right? In similarity, just follow the sequence. All your questions will be easier. Don't worry. So let me see some chats. Okay, Roger. Two angle similarity AA, perfectly fine. Because you are right, Roger. Because for any triangle, if the two angles are similar to each other, for two triangles, if the two angles by AA similarity criteria, if the two angles will be, we can say the two angles will be two triangles will be similar, because when two angles will be equal, then definitely the third angle will also be equal, because the sum of all the angles of a triangle is equal to 180 degree, isn't it? So you are right, Roger. By AA similarity, you are writing correct into the comment box, into the chat box. So anyway, so if we have taken the sequence, if triangles, yes. So in angle SPO is equal to angle QRO, this angle 1 is calculated as equal to angle 5. So these are the alternate angles, we can say. These are the alternate angles. This proved that if these two are alternate angles, if PR is the transversal, then we can say that PS is parallel to QR, which is required to be proved, right? Now, similarly, you can see if you follow the another sequence, we have taken PSPO, the last letter, the first letter, then the middle letter. Now, take the another sequence, right? First take the this one P, the first letter, then the last letter, then the middle letter. That means angle PSO. Angle PSO, that is our angle 3, which is equal to angle 3, right? In the same sequence, if two triangles are similar, we will take the another angle from the another triangle in the same sequence. So here we have taken the first letter. So here you can also take the first letter. So R will be first. This will be equal to angle R. Then the last one. R, after R it's Q. So Q, then O. So what is RQO? This one angle 6, right? So we can see this is equal to angle 6. So angle 3 is equal to angle 6. Similar alternate angle. Why alternate angle? Because angle 3 is equal to angle 6. So we can consider SQ as transversal. Then we can say SP and RQ are two parallel lines. Definitely, if they are not the parallel lines, how come angle 3 will be equal to angle 6? So proving this or contradicting this statement, we can say that angle 3 is equal to angle 6. So we can say that this PS is parallel to QR. This line PS is parallel to line QR, which is required to be proved, right? So in this way proved, we have proved it, right? Thank you, Roger, for your comments. Yeah. Roger, you are asking my name. My name is Sanjeev. Thanks. Yeah, and my channel name is Technomatics. Thank you for your interest. So, we have solved this question. And the last part of the question, thank you, Roger. Just like my videos, and you can go through more. I have more than 1,000 videos onto my channel. Okay, you can go through them if you have time and having interest. You can go through them. I have multiple shorts and live sessions. Your name is Roger. I can see you, Roger LG. Perfectly fine. You are a very nice guy. Thanks for your interest. So we just will solve the last part of this question. Last part of this question. Lol dear. So the last part of question is that if this is given that these triangles are parallel, similar, this we need to prove this is parallel. The last part of the question is that, yeah, Roger, you can put up your question, don't worry. The last part of the question is that if two lines are parallel, this criteria is given to you. Now you need to prove these triangles are similar, right? For this, if two lines are parallel to each other, in the same way as we proved over here, can't we say that if these two lines are parallel, then PR is the transversal and QS is the transversal? Alternatively, we are solving it. Just a minute. Okay. In the second part of the question, it's given that we are proving the vice versa part. Okay. It's given that PS parallel to QR, right? If PS is parallel to QR, given, this is alternate part or the vice versa. If PS is parallel to QR, then we need to prove this triangle POS similar to triangle ROQ, right? This we need to prove. This we need to prove here. I think it's visible, right? So this part we need to prove. The first part we have already proved it, right? We'll go to the second part. That is, if PS is parallel to QR, if it is given to you, then we need to prove POS similar to triangle ROQ, right? This need to prove. Yeah, Roger, you are learning. Math is wonderful. Thank you. So for the perpendicular and everything, I will come up with the separate sessions, dear Roger. Yep. So we are going to prove the alternate part, right? That is POS similar to triangle ROQ. We need to prove here PS parallel to QR. Alternate part. Alternatively, if it's given, which you have already proved, right? Then if PS is parallel to QR, then PR is a transversal. Let's say if this is a line and this is a line which are parallel to each other, right? If these are parallel to each other, then this PR is a transversal, isn't it? This is a transversal, right? Then if this will be the transversal, then definitely these are the alternate angles which are forming angle 5 and angle 1. So we can say that angle 5 is equal to angle 1. Angle 5 is equal to angle 1, right? Here we can say that. So angle 5 equal to angle 1. because POR is a transversal. POR is a transversal to the given parallel lines PS and QR, which are parallel to each other, right? So if POR is the transversal, then angle 1 will be equal to angle 5, or angle 5 is equal to angle 1. Similarly, QOS is the transversal. This is the transversal, right? If QOS QOS is a transversal to the parallel lines, if QOS is the transversal, then to the parallel lines, same parallel lines PS and QR, right? Then we can say that angle 3 will be equal to angle 6. Angle 3 will be equal to angle 6, isn't it? So here you can see, if two angles 5 and 1 are equal and another angle 3 and 6 are equals, so you can't we say that if one angle is equal and another pair of angle is equal between two triangles, then by AA similarity criteria, can't we say that triangle POS similar to triangle ROQ? I am showing you the sequence, don't worry, wait. Here you can just cross verify your answer. You can see at P and at R, both the angles should be same. So at P, what is the angle which is forming? At P, the angle which is forming is this one, angle 1 in first triangle. So this will be angle 1, right? And in another triangle ROQ, what is the first letter? R. So that should be equal to angle which is forming at angle R. So this is angle 5, right? So this is angle 5, right? So here we can see angle 1 is equal to angle 5, which we have already proven it. That is our one of the angle criteria A. From the AA, this is 1A, this is angle 1 equal to angle 5, this is 1A, right? And if you go to the another sequence, that is, let's say, angle S, then the in triangle POS, what is the angle which is forming at angle S? POS, angle forming at angle S is angle 3. So here in one of the triangle, angle 3, which we have proved that angle 3 is equal to angle 6, and at angle 6 this should be the same angle, same corresponding angle for the another part of the another triangle, right? So angle 6 is here, this one. In this triangle, this is angle Q, right? So here you can see this is angle Q and angle 6 is here, and we have proved angle 3 equal to angle 6. Here you can see. So this is the another part of this AA criteria, this A and this A. So by AA similarity we can say POS is similar to triangle ROQ. Students, make it very clear that in similarity, the sequence of the alphabet should be taken into the same manner, into the correct manner. Then only you will be able to prove the similarity of two triangles, and you can use the similarity criteria to solve your question and what is asked and to prove a statement, right? Thank you so much for watching, Roger. Now I'm coming to your comments. Yeah, Roger's math is bad. No, 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 no. Roger, it's wrong perception. You're creating a wrong perception. Math is never bad. Okay? Math is never bad. It's depending upon your interest. Okay? You should cultivate and just. No, 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 no. It's not like that. I am seeing your chat. Actually, you should have proper. Yeah. If you are start interacting with mathematics now, you'll find it very. It's a very good subject. Okay, you find it interesting, and gradually go into the depth of it. Okay, and you will be enjoying it laterally. I will say laterally you will enjoy it, right? No, it's your vision, Roger. You can just go through the videos and live sessions updated into my channel. I think you will find it interesting. That's why in many of my for the students like you or for the people like you, I'm just putting some musics also the instrumentals into some of my videos or shorts so that you will find it interesting. Okay, but as of now, if you'll go through these questions in my live sessions, I think you will not feel bad and you'll find it interacting. Okay. When you interact, at what point you are not able to understand, that should be clear. Okay. And you should put up your points, right? Yeah, at this point I am not able to. Geometric plan is bond math. Oh, no, we'll come up with the sessions of geometric also, but it's not like that. It's bond math, but geometry is also part of mathematics, right? We'll come up with the sessions of that. Okay. So I think students, in this way we have solved the questions which we have discussed. Okay, we have solved two questions. First, in this question we have proved it's given that triangle POS similar to triangle ROQ, and we have proved PS parallel to QR in this way. Alternatively, if PS is parallel to QR, if it's given to you, then we have to prove POS similar to ROQ. That we have already proved. Okay, so the both part of this question is solved. Now coming to the first part. Okay, coming to the first part. Yeah, this is the first part. Let me show you. Yeah, perfect. So here these two triangles are given, and triangle EDC similar to triangle EBA. Roger, math is interesting, right, Roger? Now you are perfectly fine. I like your statement and commitment. Perfectly fine. So here in these two triangles, we have to calculate all the angles, which is unknown. 1, 2, 3, 4, 5. So we have solved it and derived all the angles. Okay, and in this way, we have solved the questions. Okay. So thank you students for watching. I think you just like this today's session. Okay, I will come up with the next live sessions also. Actually, the board examinations are nearby, and we need to prepare for it. Okay, so that's why I'm coming with some frequent sessions so that it can help you anyway. I will feel very much good. Thank you so much for being there with me in this session. Thank you so much for watching. Just like and subscribe. Bye bye. Bye, Roger. Thank you so much for your time. Thanks.